Assalamualaikum and a very good morning. First of all, I would like to thank all participants for joining this webinar with the title of Importance of RE in Smart City Sustainability. This webinar is broadcasted live on IEEE PES Malaysia YouTube channel and Facebook platform. This webinar is organized by IEEE Power and Energy Society, PES Malaysia. I am Shakira from IEEE University Technology Mara UiTM student branch, and I will be the MC for this session. Our speakers for this morning are Dr. Muhammad NABIL HIDAYAT from School of Electrical Engineering, College of Engineering, formerly known as Faculty of Electrical Engineering, University Technology Mara Shah Alam, and Associate Professor Technologist Dr. CHOCKALINGAM ARAVIND from the Department of Electrical and Electronic Engineering Program of the Faculty of Innovation and Technology at Taylor University, Malaysia. They will be giving the talk on importance of RE in smart city sustainability. Before I pass the session to our moderator, Associate Professor Insinyur Dr. Ahmad Farid Abidin, I would like to inform you that if you have any questions regarding the discussed topic, you can type your questions in the YouTube or Facebook chat box. Dr. Farid will post the question to the speakers during the Q&A session. Dr. Farid, to you.
And again, I would like to feel or express my gratitude to our two speakers, Dr. Muhammad Nabil and Associate Professor Technologist Dr. ARAVIND, and also not to forget all the audience and participants who are keen to join our series of webinar today. So basically, the session will be roughly around 2 hours or 2 to 3 hours. And in terms of the tentative program, we are going to give the first lot, the first speaker going to be given by the Dr. Muhammad Nabil. And after that, straight away, I will ask the second panel, Associate Professor Dr. ARAVIND. And once we complete the speaker or the slot for both of them, I will post the question and we will get the response from both speakers. Okay, before I hand the session to our first speaker, let me introduce a little bit short biography on our both speakers. Dr. Muhammad Nabil Hidayat is a lecturer at School of Electrical Engineering, College of Engineering, UiTM. He already joined the academia since 10 years ago. Now he is a registered electrical energy manager from Malaysia Energy Commission, and he also certified energy manager from ASEAN Center for Energy and certified green building index facilitator from NGBC. And he also earned the qualification as a certified green manager from Green RE and certified MyCREST qualified personnel for CIDB. And also, he also secured the certified professional in measurement and verification CPMV from MGTC. Okay, that's roughly about the Dr. Nabil. Okay, let me introduce on our second speaker, Associate Professor Dr. ARAVIND. Now, Dr. ARAVIND is a head of electrical and electronic engineering program at the Faculty of Innovations and Technology at Taylor University, Malaysia. He is a chartered engineer registered with the United Kingdom Engineering Council. And now he also, instead of being head of electrical, he also heading the research cluster verticals, which is promote the SDG goals, okay, on sustainable energy and mobility. Okay, I think that's for my briefing introduction for our speaker. Okay, without further delay, I would like to call Dr. Nabil to share his thought, to share his experience regarding the importance of RE in smart city and sustainability. Okay, Dr. Nabil, over to you.
Okay, thank you very much, Dr. Farid. Okay, Dr. Aravind. So let me share my slides. So is my slide on? Okay, yeah.
Ongoing. Okay, now.
Okay. Is it on slide mode? Slideshow mode? Yeah. Okay. Okay, is it on slideshow mode? Okay. Cannot see the. Okay, all right. Okay, Assalamualaikum warahmatullahi wabarakatuh, and very good morning to participant. Okay, this is a very nice day. Outside it's the weather is very good, but due to COVID-19, so we have to stick indoors and okay, but then it will be a good opportunity to discuss on this topic. So the topic I choose is energy management for Malaysian commercial and industrial sector. So I believe that there is it really relates with the theme that we are discussing for today. So the reason I chose this topic is we just look back to a wider picture, and I think this topic is closely related to my working knowledge. Not to say that I'm expert in this topic, but this is within my working knowledge. So hopefully I can answer questions regarding this topic. So a little bit to promote about my university. So I'm a staff. I'm a lecturer in University Technology Mara, UiTM Shah Alam. So UiTM in Malaysia, we are the biggest university. Okay, we have branches in all over Malaysia, and we our university is also reputable. We have been ranked, okay, in Times Higher Educational, okay. And I am from the Engineering College of UiTM. We have restructured our. We have restructured. Previously, it was Faculty of Electrical Engineering, but now it's being merged into College of Engineering. Okay, and I would like to take this opportunity for students. For students who are interested in to proceed for their postgraduates in UiTM. Okay, so for experimental based studies, so it's open all year round. So you can go through the website, and you can explore more on further studying in UiTM. Okay. And I would like to also take this opportunity to promote our association. So I am from Malaysian Energy Professional Association, MEPA. MEPA has been around since the early 2000s. And we are a association consists of energy practitioners, industrial, mostly on the professionals, energy professionals from the industry and also from academia. So our president is from industry, and we have our vice president. Prof Komaran is a well-known academician from Uni10, and our committee members are a mix of academician and also industry. So we have our secretary formerly from TMB, and our some of our committee members are managers. Managers, they have experience related to energy management. So MEPA has been very close with the Malaysian government. We do have a lot of meetings. Meetings with either Green Tech Malaysia. We have a lot of meetings with SEDA, the MESTEC, and we do discuss on the future of energy, the energy management, particularly for energy management for industrial and commercial in Malaysia. And so yes, the benefits of joining MEPA. So we have a very close relationship with the authorities, and the association will be the focal point of communication, with the government. So the MESTEC, always invite us to discuss on the policies. Sometimes they want to frame out policies on energy in Malaysia. So either we are always being invited to all this discussion and talks. And also MEPA is working with government agencies in promoting energy management courses and energy management activities. So we are well known with our AMAS training courses and seminars. We have been working with MGTC, Malaysian Green Technology Corporation, in certifying energy managers, and being a membership of MEPA. So we do have discounts for training courses and seminars for members. So one of the benefits of being a member of MEPA. So that is some of the promotions that I have. So on the topic of energy management, so we also need to address our current situation, that is the COVID-19 pandemic. That affects our daily our current activities now. And so actually COVID-19 has been affected. So there have been a lot of literature, a lot of news before that warns us on this issue. So back in the early 2000, we had the SARS outbreak, okay, in Hong Kong. The Myers outbreak. Okay, so all this leads to it's like a warning, okay, that there will be a big pandemic, okay, that will happen. Okay, so the same thing that more closer to us, as a electrical energy, electrical and electronic engineering. So we have been talking about this energy crisis. So we do see the effects, the effects that that will happen if we don't address this energy crisis properly. Okay. So same thing as the COVID-19 pandemic. We do talk about the effects, okay, the causes, what will be the arrangement if a global pandemic, if it happens, but on the implementation part, on how to what we have to do if the actual pandemic happens, it's not what we call it, something that we need to discuss . So it's the same thing with energy crisis. The science is already there. We do depend a lot on fossil fuel, okay, and we see the effects of global warming, okay. So and recently, not recently it was back in 2011, okay, when in Japan they had the Fukushima incident. So at that time it was an energy crisis in Japan. So they had a lot of discussion on what will be the best option, okay, to replace nuclear energy and so on. And one of the options that was discussed is to take seriously renewable energy as one of the main energy sources. And but at that time, of course, we are heavily depending on either fossil fuel energy to power our grid and so on. So energy crisis is something that will happen. For I think it will happen, and it's best to discuss on how to really manage this crisis, so that we can minimize the losses, okay, in terms of economic losses and also human losses, okay. And if we look at our the Malaysian national energy policy, okay, this is what we were talking more on Malaysia. Okay, so Malaysia's national energy policy. So policies that is related to energy. So in 1974, okay, so there was this the Petroleum Development Act. Okay, so so it vested on the Petronas as the exclusive rights to explore, develop, and produce petroleum resources of Malaysia. Okay, and then the year after, we had the National Petroleum Policy. Okay, in 1975, that is to regulate the downstream oil and gas industry. Okay. And in 1979, okay, so we had the National Energy Policy. Okay, so this will be the to ensure adequacy, okay, security, cost effectiveness of the energy supply. Okay, so to promote efficiency, utilization of energy, to minimize negative environmental impacts, okay, in the energy supply chain. And the year after, okay, in during this early 1980s, we had the oil embargo. So the oil price, okay, at that time was we had a fluctuation in the oil price at that time. So the policy at that time, okay. We had the National Depletion Policy 1990, okay, and the fuel diversion strategy 1981. So that was to address the fluctuation of the oil prices at that time. So the National Depletion Policy was to prolong the lifespan of Malaysian oil reserve, okay, and the fuel diversion strategy, okay, was to pursue the balance of hydro, gas, coal, and crude oil. Okay, so previously it was our electricity generation was mainly on based on oil. Okay, but for the fuel diversion strategy, okay, so they try to diverse, okay, including renewable energy. It was for 5 fuel diversion strategy in 2001, includes the renewable energy. Okay. So I think we were quite late compared to other countries. So maybe they have been investing in renewable energy way ahead of us. Okay, but yeah, it's quite achievement for Malaysia. Okay, and so all these informations we source it from Suruhanjaya Tenaga. So this is quite the data is this is the data for the final energy consumption. Okay, based on sectors. Okay, from the 1990 to 2018. So off the chart, we can see that demand is always increasing. Okay. So yeah, as our economic increases, so also the demand for energy will of course it will increase. So we do see the final consumption. So we see for a lot of consumption is going into transportation. So this is for final energy. All electricity, gas, and so on. Okay. And the heavy users. Okay, so we can see for transportation, for residential, and for industries. Okay, so we do see that by managing energy for this sector, we can save a lot of energy to be more efficient. And this is another a very interactive statistic. Okay, energy statistic, a diagram, very interesting diagram from this is also sourced from Suruhanjaya Tenaga, but this is in not the latest one, is 2014. So we can see the connection between the generation and also the consumer load. Okay, So we do see the percentage, the amount of energy generated, okay, within the fossil fuel. Fossil fuel, we have oil, okay, generation from oil, natural gas, okay, hydro, okay, and also coal. So in 2014, most of the power produced is by natural gas. Okay, so and also natural gas. Okay, some of the improvement that okay, you have natural gas will also feed cogeneration, cogen. Okay, so cogen, it's something that we try to reuse the industrial heat waste. Okay, so reuse back the waste into generating electricity. Okay, and we do see the participation of renewable energy on biomass, okay, on methane gas from landfill, okay, being a hydro, and recently picking up is in Malaysia is not picking up. Mostly most of the RE projects in Malaysia is in solar PV. Solar PV. So here in statistic from 2014 shows that in the renewable energy cluster, it's the percentage of electricity generation that is fed to the grid is only 0.15%. Okay, and we do see that most of the energy generated, okay, a large portion is going to service the commercial sector, which is accounted to 31%, and also the industrial sector, 37%. So most of the energy, okay, about nearly 60%, okay, goes to serve the commercial and industry. So yeah, that is why actually if we look at the energy apportioning, so if we can improve our commercial, okay, and we make it commercial, and our industry sector, we make it more efficient. Okay, so we can save a lot of we can reduce the energy, and also we can reduce a lot of CO2 generated. Okay, so the statistics is in 2014. So if we of course, if the latest statistic, if it's 2031 with the effects of COVID-19, so maybe it would not be a good baseline in order to discuss, because all of the economic activities and lockdowns. So yeah, so that's why we put in the statistics in 2014, so it can show a very good explanation on the to show the baseline. Okay, and here we also so this is from SEDA. Okay, charts from SEDA Malaysia. So so this is installed capacity, okay, of RE installation. So by definition of SEDA, so we have our RE, renewable energy. Okay, they categorize it into biogas, biomass, okay, biomass solid, okay, small hydro, and also solar PV. And we do see that okay, solar PV is the installed capacity is very high for solar PV. So this is because of several factors. Mainly because the weather. So for Malaysia, we do receive a lot of solar radiance. So our solar radiance is quite high, okay, in Malaysia. And but the most the reason, the main reason why solar PV is the installed capacity is high for solar PV is because of the FIT. Okay, so previously it was the feed-in tariff scheme that was offered. Okay, and feed-in tariff for in the early days it was quite lucrative. So back in the days, one kilowatt hour is they can sell 1 kilowatt hour to nearly RM2. So RM2 for 1 kilowatt hour, which is you can make money lah with that kind of rate. Okay, so we do see people, okay, organization, they okay, companies, they go for this okay, solar PV, okay, to get the quota for FITs. And so I believe they stopped FIT, so it wasn't a permanent program. So it stopped I think in 2018. Okay, when so within the years since solar installation, so the price of installing solar PV is getting cheaper. Okay, so the government also reduced the FIT rate, okay, to meet the current price of solar PV installation. But in 2018 they stopped this FIT, and they changed it to NEM and so on. So there we can see that the the installed capacity for solar drastically dropped starting from 2018, 2019. And but then they still offer LSS, large scale solar LSS. So we have so it is more like a competitive bidding, LSS. So they will negotiate the price with DNB. Okay, so but then the rate is much lower compared to previously FIT. So for most probably for large operation, for large scale operation, it will be profitable. And due to the installed capacity, so for Malaysia, we see the most of our RE, not most, most a significant portion of electricity generated by RE is by solar PV. Okay, up until 2031. Okay, so this comes to our discussion lah. So most okay, yeah, this is based on the discussion within the energy managers, within this discussion of in MEPA, in our meetings, in Malaysian Energy Professional meetings, so they okay, they really highlight on this what you call it, we need to, you know, we need to get our energy managed first, okay. So we see that the government, they really promote on renewable energy and so on, but the important thing that we need to do first is on the energy management, So we can say that say like in our what you call it, pipe, okay, pipe. So we let's say if we put this analogy, this our pipe, so our pipe, either we detect that our pipe in our house, so the water pressure is low, so instead of investing on let's say buying a new pump to increase the pressure the pressure of water, okay, in your house, we do need to check for leakages, okay. So we need to have you need to check our leakages before we invest on buying new things, so based on our experience in energy audits, so so we do see more potential savings, more savings can be achieved, okay, if we settle the if we improve the existing operation, if we realign our behavior towards energy, for example, okay, human capital training and development, so it will be more faster and more cheaper to do energy management over than to invest in renewable energy, so so on the last iGEM, okay, that we had some presentations from energy managers, from hospitals, okay. So energy management in Malaysia is being practiced by most of the hospitals in Malaysia. So basically the return of investment in for example for solar, the ROI for installing solar PV system will be around 5 to 8 years, okay, 5 to 8 years. And whereas some of the reports that have been presented in iGEM, in the conference, iGEM conference, so they state that by doing energy saving measures related to energy management, so the ROI can be as less as 1 month or days, okay. So this will be more what we call, we try to tackle the hanging fruits first, okay. And for energy managers, actually renewable energy is it comes under the energy management lah. Okay. So in not to say that of course renewable energy is a very wide topic, but in the topic of energy saving measures, so we have options on for example for renewable energy, installing solar PV and so on. So it should come under energy management lah, energy management first, okay. So like what we discussed before, Okay, so there are more opportunities, or more opportunities that we can go, we can go through, and for energy saving measures under energy management. There is what we call it is the ROI is shorter, and it will be more sustainable So yeah, this one the renewable energy should come up after energy management is something that I believe is something that that is true from my working knowledge And we do see that okay, so this is an interesting slide from IEEE energy balance. Okay, this is quite old data in 2014. Okay, so this is presented during the previous iGEM conference. We do see the energy consumption. Okay, energy consumption per GDP, which it can be a good index for us. So how efficient we are in using our energy. Okay, and of course, if we look on the worldwide index, so so based on the index world, so it's 2.5, and Malaysia is quite in behind We are 4.3. Our index is not that good 4.3. So yeah, if compared to other countries, so basically we compare to Japan Japan is one of the best. Japan compared to Japan in terms of energy efficiency. So we have a lot of improvement that we can do. Okay. So, but we are not quite that bad 4.3. So compared to other big industries, for example in China, in India, okay. So but then we need to improve our consumption per GDP. And some of the initiative that is taken. Okay, so energy efficiency initiative. Okay, so we have all this initiative. Okay, starting from promotion of energy efficiency in the 7th Malaysian Plan. Okay, the MYEP program. Okay, in 2001, the development of the Malaysian standards. So this is quite very notable standard MS 1525. Okay, so you have energy audits happening in 2002. Okay, we have guidelines development of guideline in 2006. Okay, and notably in 2008 we had our EMA, okay, energy management of electrical energy regulation, EMA. Okay, we had GBI, okay, Green Building Index in 2009. So a lot of programs, EPC programs started in 2013. Okay, guidelines for EPC, energy performance contracting in 2013. Okay, and we are still having a lot of ongoing programs. Okay, so the recent one will be the EACG Energy Audit Conditional Grant, which launched in April this year. So yeah, we can say that the Malaysian government is very serious on tackling to improve our energy efficiency lah, in Malaysia. And so some of the okay, so this is a statistic based on the previous EACG 1.0 that was from 2015 to 2020. So this is some data that we pick up from Green Tech Malaysia. So at that time, for EACG 1.0, the EACG for industry was under Green Tech, and the EACG for the commercial was under SEDA lah. So if we look at the potential of energy saving measures, okay, so this is based on the audit, okay, audit that they have done for 40 industries, and so we do see a lot of potential energy savings in thermal, in thermal and pumps, within the value of 40 million kilowatt hour, okay, 40 million kilowatt hour annually, which is huge, which is very high as compared to if we install solar PV, for example, solar PV that can generate. Okay, so if you want to generate 40 million kilowatt hour, okay, so you need a big system lah, solar PV, and of course the cost of building the system will be expensive, so and the return of investment will take some time lah, so having to tackle this potential energy saving measures by the system, so I think it will be more beneficial beneficial in terms of the ROI, and to increase the efficiency overall efficiency. So this is for the industries, and this is some of the this is based on energy audit, on recommendation. So in terms of cost, the low cost, low cost or no cost, so already you can save almost 20%, okay, by implementing what we call, we don't say no cost lah. I think no cost is low cost, so okay, low cost. So of course you need to invest on the meters and so on, so there will be cost lah, but for no cost and low cost is nearly 20%. You can achieve 20% savings, okay. Again, if we translate it into generating using renewable energy, so that will be more cost effective, okay. Energy saving measures, okay. We do see again on if we can improve the operational control, we do see that operational control, okay, it has contributes on the energy saving measures, ESM around 42, nearly half, okay. So again, if we instead of investing in RE, okay, so I think it will be more economical to invest on improving our existing system lah. Okay, yeah. So for example, using more efficient chillers, having a better operation control, installing energy, building control system, BMS, building management system, and so on. So that will be more better lah. Okay, and what is changing the energy and utility industry? And so this is from IBM. So there was for in 2014. So we participated in a very interesting conference. So there was a presentation from IBM. So what will be the changing in the energy and utility industry? And we can see that the grid is getting older. So at that time, 60% of the electric grid asset will be replaced. Okay, in the decade. Okay, and we see a lot of alternative energy enters the grid. Okay, so mostly in Europe, they have a lot of wind generation. Okay, and in Europe, you have smart meters. Smart meters are becoming mainstream. Okay, so at that time, smart meter is meters that they track down the energy consumption, and the data can be real time lah. But then I see the future of smart meters is not only they capture the energy consumption data, but also they would have they can also capture the what we call it, the other variables, other variables that can be that will be important also to capture. So of course it's important to capture energy data, okay, energy consumption, and also is important to capture the consumption data. Okay, so for example, when we did energy auditing, so we know that there are two important data that we need. That is the consumption data, the energy consumption data, and also what we call the independent variables independent variables. That is the let's say the chiller, okay, the data of the performance of the chiller, the data, for example, for occupancy and so on. So this will for having all these data so this data can actually present the actual energy index. So not only we need to know the consumption data. So actually, if we have what you call it, smart meters, smart meters can eventually calculate the energy index usage, okay, for that facility and so on. So I can see that the future will be on this smart meters, okay. So not only on capturing the consumption data, and this leads to the what the consumer wants, So they want more control and insights into the consumption. Okay, so of course the increase of energy price. So the energy price is getting more expensive. So of course the consumers they want more control. Okay. So this leads to what I believe the importance of big data and analytics in energy management. So Also in renewable energy, okay, big data, that will be the future lah, big data and analytic. So based on our experience lah, conducting energy audit, so we are handling a lot of data, okay, and useful data, okay. So not only data on the energy consumption, okay, we also have data on the independent variables, okay, and I can share one of the experience that we have done for for Malaysian hospital. So recently they wanted to set a baseline for Malaysian hospital, okay, from MOH. So actually, in order to set the baseline, okay, so in order to what you call it, to presume the index, the energy index for hospitals. So there will be a lot of data such as patients, number of patients, number of beds, equipments. We also look into the weather. Okay, all this data is okay. So it's quite significant in order to dictate the energy cost, energy index. Okay. And we see that the importance of having big data, and in Malaysia we do see a lot of research on this area also, in energy management, big data in relation to energy management. So we can some issues, okay, issues using data science, okay, in energy management. Okay, so I think what is heavily researched now is on the failure probability modeling. Okay, so the efficiency of the machine learning algorithm, okay, in detecting failure, prediction is without a doubt. Okay, it helps to increase performance. It predicts occasional failures function. So all this is to reduce okay, to reduce maintenance costs, and also to save money. Okay. So so the output of the failure probability model application is essential part, okay, in the decision making process, okay, for the utilities. Okay. And I think most of the research is a lot of research is being geared into with this. And also we can see that another outage detection and prediction. Okay, so people tend to regard blackouts as failures in electric grids. Okay, so by having blackout preventive measures, okay. So also this is also heavily researched. Okay, we have automatic protection system operation. So the modern smart power outage communication is capable of, okay, they can predict the influence of weather condition in the power grid. Okay. Predict impact of near-term asset values, okay, on the power grid. Okay, detect outage in specific areas. Okay, and real-time filtering of outage inputs. Okay, So yeah, so every single outage events is carefully analyzed, okay, and to identify the root cause, okay. So then after that, the predictive algorithm may be applied to model the future likelihood of the outage. Okay. So the smart energy outage ecosystem, it allows accurate real-time outage status. Okay. And okay, in dynamic dynamic energy management, okay. So it plays a leading part. Okay, it empowers the dynamic management system lah. Okay, in smart grids. So it contributes to the optimization of the energy flow. Okay, between the generator, okay, the providers and the consumer. So so the efficiency of the energy management system, okay, depends on the load forecasting and renewable energy resources and so on. So dynamic energy management system, it provides vast quantities of data, okay, obtained by practical method and solution. Okay, it helps to make performance estimation and provide smart recommendation for energy management. Okay. So also data science, okay, in energy management, we have smart security and theft detection. So this will be some of the problems lah. Okay, so because energy theft is actually expensive. Okay, it's an expensive type of theft. So having securities, okay. Okay, so having big data, okay, and analytic, so the solutions may be behavior based, okay, and it constantly tracks the user's behavior, so yeah, it's very useful, Okay, and also for preventive equipment maintenance, okay, also this will help, okay, to monitor the equipment condition and performance. Okay, so yeah, okay, so the basis of the output, okay, the smart system, so they alert the energy outage, and the poor functioning of the mechanism. Okay, so this will help to help maintenance, to take immediate decisions lah. Okay. Okay, so and also for demand response management, okay, same thing, so to strategize, okay, for real-time specific real-time management application and solution to monitor the metric of energy use, okay, define the activity pickup and adjust the energy flow to current demand rating. Okay. So also using data science in energy management for real-time customer billing. Okay. So the software, okay, it tracks the operational activities and transaction in real time, and it takes immediate actions in terms of billing, payment, prepaid. So billing will be a problem for power utilities. So in the case of TMB, okay, there was an issue on customer billing on the first EMCO, on the first lockdown. That was in 2020. So the customer received the bill, which is okay, 40%, okay, 40% higher than usual. Okay, so usually this is because of the of the what you call it, the billing period. So at that time, TMB didn't send their meter readers to read the meters. So that was quite an issue. So having smart meters, okay, using data science, okay, to have real time customer billing, it will be very okay. You can solve this problem. Okay, and also improving operation efficiency. Okay, optimizing asset performance. Okay, so a lot of things that we can see. Okay, and also enhancing customer experience. Okay, so in
Dr. Nabil,
conclusion,
sorry to interrupt, Dr. Nabil. You
okay.
have 5 minutes more.
Okay, yeah. So in conclusion, okay. So in conclusion, we have the energy, the okay, utilities under constant pressure, okay, to provide high quality services. So we have a lot of demands. We want energy, electricity, which is affordable and also non-interruptible. Okay, so so you can see the future, the future of using data science. Okay, machine learning, okay, algorithm and analytic models. Okay, big data solutions. It will help. Okay, to manage and efficiently use the resources to control energy flows. Okay, optimize work. Okay, avoid mistakes. Okay, so real time use of predictive analytic and data science. Okay, but it requires investment lah. And readiness to face the challenge and introduce a new complex operation. Okay, so all in all, in objective is to benefit, okay, to benefit the customers lah. Okay, so the benefits of data science application, okay, in energy and utility, in energy is very large. It's enormous. Okay. So for that, this will be my okay presentation. Okay. With that, I end my presentation. Okay. Okay. So thank you. So I'll pass the stage to Dr. Farid.
Okay, thank you, Dr. Nabil. There is a lot of data, a lot of statistics have been shown. Okay, but we are going to wait until the second speaker when we open the questions. Okay, now let's we go to the second speaker, Associate Professor, Technologist, Dr. ARAVIND. Okay, over to you, Dr. ARAVIND.
Yeah. Allow me. Okay, I hope that you can see my screen in full. Can somebody confirm, please? Yeah. Okay. Thank you very much for the opportunity and happy morning to all, especially to Dr. Ahmed Farid, Dr. Kanendra, and the team from the wonderful team from IEEE PS Malaysia chapter, and particularly with the UITM student chapter. It's really exciting to be part of this sustainable series. I call this sustainable series. And share some of my thought process towards the smart city sustainability today, right? Okay, so I'm representing Taylor's University. As I mentioned earlier in the introduction, I'm heading the electrical electronic engineering program. At the same time, I'm also heading a research cluster, which is called Verticals. Verticals stands for Value Enabled Research. research through innovation catalyzed towards long-term sustainability. As you see from our vision of our research cluster, we want to develop solutions that can really add value to the society at large, right? So whatever the research we do at our labs, we want to make sure that it is reaching out to the common man or to the society at large, right? This is the theme of our research cluster there. And of course, this sharing session, I will try to bring you to a journey, which is more not to say it's much technical aspect, but to give an easy way of understanding the keywords of what I have put in the title here. Right? Sometimes when you see words like sustainable, smart city, all these are actually misleading, and it is interpreted by different people in different ways, right? So this presentation, I will give you a dimension in which I see this as sustainability, and how we need to look forward in making the answer for these challenges, which is already prevailing or is going to happen in the next 30 to 40 years of time, right? How we can slowly embed some of our responsible actions, right, that can make this so-called city sustainable, and making it to become more smarter there, right? Okay, so my content of presentation today will lies in this sequence. I will explain, or I will introduce you why we need to be worry about this sustainable at large, and particularly when we talk about city sustainability, why it is very why it is highly important for us to understand the need for this city sustainability there. Then I will also explain some strategy how we can address this smart city sustainability, and I also will tell you what are the strategies that can be done in order to address this issue there. And finally, I will show you an example of how we at our lab how do we address this smart city sustainability issue with an centralized air conditioning project, right, with an industry locally, right? And towards the end, I will take a few questions if you have any over there. Okay, the first question is like why we need to have think about this sustainability at large, right? Okay, so typically people move from the rural side towards urban side. Uh, Specifically, is because urban is more connected with almost everything, right? People move to cities because they want to have a better education. People want to move to cities is because of a better opportunities available. So better opportunities here means like it can translate into job, or it can translate into some sort of business value for them, right? The moment you have a better education, better opportunity, that means you are placed in the society at a very higher position, right? That means you increase your or put your standards, living standards, to be a little bit higher from that, right? When the living standard become higher, that means your demand is becoming higher. So probably you might be needing a car, maybe 2 cars or 3 cars, right? So putting this what is called like these extra things into the same land area, because the city is congested with the same area, right? But we are putting more people, we are putting more machines inside that, right? Now the city is actually bulging out from the, that is mean the ratio of the population to the land area is actually bulging a lot, right? So this one we cannot avoid, because the GDP of the country, or GDP of the of all on its own, comes from mostly from the urban side of the component. As you can see from this graph here, the trend of the rural population moving to the urban, or you can say that the ratio of the rural to the urban is dipping, and rural is almost reaching the saturation component, while urban is actually keeps on moving at a larger pace there. Okay, so if you look at from the statistics of the Malaysian perspective, right, urban population versus the GDP per capita, you can see there is a tremendous increase in this ratio there, right? And this makes the livable of the people. Livable of the people here, I means like not only the people, even the machine, the lifetime of this machine used, lifetime of the car used, right? It's become a question mark at last, right? So we need to make an alternative to see that how to make this to become more sustainable, right? Um, uh, like this is one thing we need to think about it. Okay, to make it to become sustainable, what we need to do is we need to pump in more sub-components of what it is required to become a livable society, right? Starting from energy, you name it, everything, right? Everything around you, including up to the health aspect, right? And we want this one to happen for commonly for everybody in the city there, right? So that is what we call as an equitable society there, right? We want to have the same energy available for everybody, right? Or we want, in other words, energy is available throughout 24/7 for everybody in the city, right? At the same time, we want to have a example, for example, like we want to have a health facility available to all levels of people within the city there, right? So to make it to happen, like to make this energy to be available, to make this health to be available, similarly the sub components to be available, right? First thing what we do is we try to build up put in more money to build more infrastructure, right? For example, in energy, when the demand is becoming high, probably you are looking for more energy source, like at the source itself, or we try to, for example, you can see the number of transformers coming into the roadside, right? Right, these are actually putting up more money into the system at the same time to make our living to become better. But to make this balancing of livable to the equity, right, that is available to everybody, we need to monitor the whole system there, right? So you need to have tools that can measure the living standard, whether it is being shared by all the people within the society, right? At the same time, we also want to use the technology which is available with us today, right? And it is rapidly growing, right? If we embed this into together, right, then we can make sure that whatever the money we put on the infrastructure, it is actually making it to become like a quality aspect rather than the confinement of certain infrastructure in one part of the city there, right? So that's where this quality comes into the picture here, right? So we want to have a society which is livable to everybody, right? And this society should be able to sustain on its own in terms of economy, right? In terms of the number of people versus the GDP of the country, right? Once we have these two balance in place, then the quality of your life or the living standard will become better, right? Of course, when we say infrastructure, we put in money. When we say system operation, we put in money there, right? So when you have to put a lot of investment on this infrastructure system operation, of course there should be a business value between these two, right? If there is no business value, that means if this two is not translating into an increase in the economy or increase in the GDP of the country, then it is a risky business, right? We put so much of energy source for the industries in the city, for example, and these industries are not generating a profit base, then it is not a worthwhile for us to pour into it. So the important aspect what we need to also look at is whether this infrastructure to the operational is giving us a business value or not. That means business value here, it doesn't mean that it's we calculate in terms of ringgit or dollars or whatever maybe. It's calculating as whether it is translating into number of jobs, right? Number of employment opportunities for the people, whether it is creating an opportunity to have a balance between the gender, right? So these are the things is what we call as a business value, right? And of course, this is bounded by the regulations of the local body, maybe the governmental and the semi-governmental or the NGOs in place, right? So if we, when we do as a city sustainability model, if we take care of these components in place, and I believe like this will, even at this design stage itself, right? Then it will actually gives us a framework where we know that this system is going to be sustainable at large, right? So we know that in some part of Malaysia, if you go towards, right, there are a lot of construction or new what is called like households are there, right? But it is not sold or unsold to people there, right? Any place, as you know, that any place which is not sold, right? You put money on that, if it is not selling or if it is not translating into a return of investment, then it is not going to be a viable business solution there. So that's why business model becomes a very, very important aspect. Even though we talk about supporting for the energy demand, at the same time we also need to look at while supporting this energy demand by putting a new infrastructure, by putting a new tools and technology, whether it is going to translate into an economy aspect or a return of investment like that, right? It's very, very critical for us to think about it, right? So of course, when you look at this aspect of balancing out of these three triangle, which if you are from the innovation cycle, you will be knowing these three are similar to the innovation cycle, where we have the desirability, viability, and also the practicality of the product. That is the center point of the innovation component, right? So if we want to address this one at large, right, we need to have some sort of innovative approaches, innovative systems, innovative components that can address towards the sustainability of this whole system, right? Okay, let's take the example because we are talking about energy today, right? And let's take the simple case of energy availability within the city. So as of today, I think what we know is like when there is a demand, then you have to cater for the supply, right? When the demand is rising for some reason, then the TNB will try to support using the existing fuel, right? Probably they can make the 1 unit of the oil powered station, right, to be put in action, right? Instead of one running, probably two is running to cater for this particular supply chain. Or you can come with a renewable alternative that can support for this demand, right? But if you look at the graph on the right side of my screen there, right, on the x-axis you can see the resources. On the y-axis you can see about the year count, right? If you look at around 50 years of time from now, right, the oil will become completely depleted, and so as the gas there, right? Coal can survive for the next 100 years of time there. Okay, so technically, by having a graph like this as an a professional, as a data scientist or data engineer, we feel like we are okay, right, at this point of time. But we need to also think about what is going to happen in the future there. So that's what we call about the sustainability, and the global goals is calling for people around the world to come up with an alternative or a solution that can lift this bar a little bit, so that we can delay this year to a higher aspect from that, right? So of course this one we cannot get away from this. After 100 years, definitely the goal is not going to be there, right? But at least we can delay this process to a little bit higher, right? So that's what we call as a responsible supply chain. So we are no more looking at demand is equal to supply, but rather we are looking at making the supply chain. That means starting from the production of your energy from in a power plant, right, until you utilize in your home, whether you can convert the whole process into, or whether you can support each of the subcomponents from the supply until the load side, right, to become more uh, responsible. So in other words, if you want to tell in a common language, try to reduce the losses within this whole structure there, or try to see that wherever the ways in which we can minimize the impact on the system, right, then it becomes like a more responsible action there, right? So many ways can do, right? The simple way is like when the supply is rising, when the demand is rising, for example, you can straight away say that I want to increase the generation. When I want to increase the generation, I need to go for the resources, right? If the resources, whether it can be non-renewable or renewable resources. If it is a renewable sources, whether it is going to be cost effective for me or not, right? There's no point for you to put about 1 acre of the solar plant, right? And 1 acre of land is wasting its land space. Probably you can use that one for some other activity, right? So you need to come up with some other alternative, whether we can some other ways in which you can make the solar plant to become more viable. Then probably you have an elevated structure of the solar panel, so that at the bottom you can have maybe some cars, highways, right? In the highways you can put an elevated structure over there, or a divider of your highway where you can put a wind turbine, for example. These are some of the things which you can think about to add more value for the system. So the important aspect is what we miss out is like when we think about energy, right, we just go and buy a solar panel just for, we don't look at the space it is going to occupy, the maintenance is going to create, when it is going to give you the return on investment, whether it is going to be a viable solution. This is the challenge we forget when we talk about this sustainable aspects. And of course, optimize consumption, right? Reduce the leakage and recycle residues, right? The key aspect in the whole process is these two. So it's not about increasing or optimizing the consumption, rather than looking at the reducing the leakage and recycle certain parts there, right? If we concentrate on these two, then I think we can prolong prolong this sustainable, we have more time for us to come up with a new solution over that, right? This one, if you look at the demand is rising with the city condition here. What we are today is like we look at the non-renewable as a prime source, right? Of course, we look at the renewable. Typically, as we know that we look for energy can harvest from the sun, wind, or maybe from the ocean, or from the fossil fuel, or from the vegetable oil. These are the things in which we are looking at an alternative to support for the non-renewable system here, right? So we just measure the demand increase, and we say that, okay, I want to reduce the load factor. Probably I can put a renewable plant here. Because government is supporting with some incentive, right? Then we can say that, okay, I'm reducing the grid impact, right? Grid impact by putting this renewable source over there. Right? So this is what we are now today, right? So when we want to move towards the next step of correlating this renewable to mapping that with available non-renewable sources with that of the load, right? Then that is where with this what we call as like digitalization of the system happens, right? Where you try to monitor the whole process, right? Monitor the load, monitor the resources available, balancing out with the renewable options there, right? So that's what we call as a monitoring the demand, right? So from the monitoring segment, we know that typically like when the load curve is becoming peak, right? How to cater for this peak load, those type of things is what we can do using this type of things. And of course, technology plays a major role, like your sensors, use of, for example, some sort of IoT cloud-based monitoring, right? Data analytics, for example, to come with an intelligent or an optimal solution, right? Is what this monitoring phase will do. But moving forward, when we want to move towards, for example, 30, 40 years of time, we want to make this one to become like a intelligently sustainable on its own, right? So that means in the future, we expect each of these renewable, non-renewable, the load, the several components of the within the power system talk to each other and come up with an optimal balancing out of the supply to the load component. This is going to happen in somewhere in 30 to 40 years of time, right? That's why we call it managing the demand intelligently by on its own. Right? Okay, this what is what we need to know as why we need to shift from the renewable towards the society here. So be mindful, like renewable is not equivalent to making the system to become a sustainable solution in the long run, right? It is only a makeshift arrangement, right? Making this renewable to work for you, work within the economical aspect is what as an engineer, as a future engineers, we need to be looking forward in that, right? Okay, let me put like how to build this sustainable framework, right? That's what I'm going to present in the second half of this presentation, the how, right? So we need to build the infrastructure, definitely yes, because we need to have more demand coming in. So you need to build a better infrastructure, right? That can cater for this demand at large. Right? At the same time, we also want to make sure that the operation is managed at large here. So the key components in the sustainable the framework is you need to build infrastructure. At the same time, you also need to look at how this infrastructure is going to be a viable alternative for you in the future, right? So that means we need to have a business value in mind. What type of business it's going to create for you. As I mentioned earlier, also business doesn't mean dollars. It's basically it's creating a job, maybe an opportunities, maybe work with an international team, like getting funding from the international framework, getting funding from international bodies, right? National bodies and international bodies. This is what we call as a business model over there. At the same time, we also need to take care of this market regulation. Regulation here, it means like what will happen to the end of this infrastructure you are putting in there, end of life cycle of this infrastructure you put. For example, you put a solar panel, right? What will happen after 6 months or 6 years or 7 years of time, right? Whether it is can be recycled or whether it has to be dumped into the mother earth, right? If it is going to be put on the earth, what is going to be the impact or the effect of this one onto the environment at large, right? These are the things we need to take care in this market regulation. Okay. If you have all this plan at the initial stage itself, right, then you have a clear sustainable model. In most of the cases, what we try to do is we don't worry about these two cases. We don't care about what is going to happen to the battery we are going to use in our solar panel, right? We don't care about the solar panel issue. For example, if solar panel is getting shorted for some reason within its structure, right? What we do, we just throw the solar panel. Probably it can be used for some other low energy application at large. Okay? So this is what we need to have in mind before we think about uh, all these jargonic word like sustainability, smart city, sustainability. There, okay. Within the infrastructure, probably you can look at these three aspects, right? There are many aspects, but I'm picking these three aspects as a key component which you need to look into. That one is decentralization of this component. Whether this the whole infrastructure you're building, you are built in is similar to that of a Lego model. Lego model means, for example, you connect a Lego in one fashion, it will create one model, right? If you rearrange in a different section, right, it will give you a different model, right? This is what we call decentralization. Meaning that, for example, if you have a car, electric car in your home, all right, whether this when this electric car is stationed at your workplace or your home in the morning, for example, whether you can put a solar panel at the top so that you can charge the battery or not, right? Whether this car can also feed in some energy if there is no electricity or some part of electricity you need, whether this car can become like a power source for the system or not. This is what we call as a decentralization of the infrastructure. So meaning that you build an infrastructure, you should be in a position to remove certain part and put it in for example, you are using a technology of 3G now, right? We know that 5G is in maybe in the next 3 to 4 years of time, 5G will be in full operation. Whether the current infrastructure can adapt to this 5G network or not. This is what we call as a decentralization of that. Okay. Second one is digitalization. Of course, digitalization, we want everything to be connected to your phone. You want to monitor everything through your phone. For example, wallet is an example where you can use for anywhere in your usage there, right? The third one is on the flexible, right? Whether this one is adaptable for the universal aspect, for example, universal aspect. For example, you want to trade energy between the border of Malaysia and Thailand, right? So probably they will be they are having different operating voltage, operating power, right? Whether when you are doing a trading part, whether your system, your infrastructure you are creating, is it adaptable to your partner? So as we know that Malaysia is moving toward digitalization of the most of the substations, and by 2030, it's expected at least 70% of these power stations will be replaced with the digitized substation there, right? And the substation which is closer to the Thailand, whether they can be adopted, they can share this or sell this energy to that area or not, right? That's what we call as an universal component. So an infrastructure, when you want to develop, it should be decentralized, it should digitize, it should be flexible. A simple case, when you are doing a solar project in your lab, right? You have solar panel there, you have a battery, you have a motor to do the angle, tracking angle, right? All these one are subsets of this whole infrastructure, right? Whether it is possible for you to take out certain components or a full component of the solar and reuse in certain application, or when the solar is not operating in the night, right? In the night, it is not going to be used. Whether this motor can be used in some other application or. So this is how we have to think in that type of infrastructure building there, right? So it will automatically, slowly we try to do this aspect there, and slowly it will try to address these sustainable goals at large. The example case of the, I think most of you from energy side or power side will be knowing this VPP, which is going to be the future power plant system here. This is an example taken from the Singapore's 2030 goal, where they want to convert or they want to integrate everything into the cloud-based energy sharing platform, right? Where they want the system to become intelligent, system should be reliable, and system should be resilient on this one. Resilient here means any load fluctuation from one component should be automatically managed by the system over there. So here, if you look at all the aspect here, it has all the subcomponents of what you are seeing as an independent unit, like a solar system will be there. There is a commercial, there is a housing, there is a residential home, and no, like even the conventional power plant can be part of this one if you move that one to the component, right? You optimize it, you aggregate at one point, and you predict the demand, and you push the load to that particular component. All these are maintained through the virtual component, which is basically a cloud-based operation control. Okay, this is what the vision of Singapore in Singapore Green Plan for 2030. The second component is system operation, right? System operation is I put this one in two components: health and system care. Health doesn't mean the physical health; it means like whether the system you are putting in place to make this or manage this infrastructure in the long run, whether is it a viable solution for it, right? Whether it can generate you with the most economic aspect here or not, right? So whether it is cost effective or not, right? Whether the system you are putting here is resilient for any adoption of a technological growth or technological advancement there, and how far the system is reliable. Because when you trade between energy user, consumer, and the prosumer, there is a trading platform, right? The trading platform involves money costing, right? So it has the issues of theft or security aspect over there, right? So that's what it means by the health component concept. At the same time, we also look at the system side aspect here. System side is very simple because you are connecting everything through a cloud base. The important aspect is the cyber security at large. And of course, when you want to have an action that is taken because of some during the operation, you want to, for example, isolate a certain power plant subsection from the whole virtual power plant, the one I showed you earlier, right? There should be some sort of electromechanical actuation system is there, whether they can provide that type of mechanism or not. Right? So these are the things we need to take care in terms of system component. Both these one are built on a technology platform, right? Then we have an embedded platform that can typically the embedded platform consists of a sensors, your IoT, or whatever may be. A technological platform, as you know that there are several players in the market, right? And of course there should be an intelligent algorithm or intelligent a processing part, right, that can control this, monitor this health and system. At the same time, it can interact with that of the infrastructure at large here, right? Example is a digital twin. Digital twin, I think you heard about this word in quite often recent times, right? In the normal condition, what we do is we come up with a plan blueprint, then we go to the site, we develop the system, then we execute it straight away. In digital twin, what we do is it's just like a parallel prototyping. While you are doing the aspect of the design at different stages there, you automatically simulate that type of environment in your lab level, right? This is what they call as a digital twin, right? Twins basically is a replicating of what is actually in the existing. This is an example of a Hangzhou city in China, where they use this city information model there. So right from starting from the planning stage until the management stage, everything is done parallelly in the lab, right? What will happen after you develop this planning stage? They look at if, for example, landslide happens or a tsunami suddenly happens, what should be the mitigation plans they have to do, right? It's basically like a agile method. Basically, you try to make a quality improvement each and every stage there, so that the end product is more resilient compared to that of what we do at the planning or the construction stage of the management component, right? So in normal case, it will be a black box. You design everything, you plan everything, you put everything, you put in the black box. The end of the black box will be the product, the infrastructure you develop for the system. Okay? In digital twin, what we do is we interfere at each and every part of this, right from the design until the execution stage, right? So that you can have a thorough model of the system. Okay. So this one also we do in our Taylor's University, where we do the 3D prototyping structure. In lab, right? We design a system where you can have a digital twin, where you can have, while the 3D printer is printing the system there, we also have a system to monitor. We can also have a system to control using the cloud-based system. Right? So I'm not putting that one here is because it's not relevant, but if you want more information, you can write to me. I can share the paper regarding the digital twin, how we develop at Taylor's University's vertical research group there. Okay, so we talk about infrastructure, we talk about the system operation, and of course, as I mentioned, there should be some business value between these aspects there, right? So business value, as mentioned by earlier speaker also, there are different type of business model. Even the regulatory bodies is coming up. Even your own also, you can have your own business model. Like as I mentioned in our last, whatever the product we develop, we make sure that there is a business value even at the start, even at the design stage itself, so that we know that exactly like who will be our consumer and what value this will be going to generate when we want to commercialize this product into the market. Okay, a net energy meter is one aspect of aspect here. FIT is also another aspect here. Of course, for peer-to-peer energy trading, right? When costing is involved, of course, you need to have some sort of digitized, what you call as like uh, digitized monetary benefit. That's why you bring the blockchain as an aspect from here, right? The trading part here. And of course, this is wholly bounded by consumer, prosumer, and of course, agency. This is where the regulation bodies comes into the picture, right? So if there is um, any stealing happens in between or any intruder happening in this between, what should be the action plan? How far this trading is secured? How far government agencies are involved in this component here. And I think Malaysia is trying to put up several pilot model in developing this peer-to-peer blockchain using a standalone house which is which is able to generate a solar energy, right? Then they are trying to sell that one to the EB, TNB, right? Then TNB sell to the several customers. In the future, this TNB will not be a player, so you can straight away sell to whatever the players you wanted to do over here. Then of course another one aspect which we also now booming up is the second life. For example, the batteries, which is inevitable in almost every application, right? Whether these batteries having a second life, right? For some secondary application, right? One, for example, if you're using a battery for a car might be needing a very high voltage, right? Whether you want to use for another localized application where the voltage level is lower, the current charging time is lower, probably you can reuse that one for this aspect here. Okay? So this also is a very high market there, right? Because as you know that every government is looking towards moving towards electric vehicle, hybrid electric vehicle, or even renewable energy, and all this renewable electric, all this needs a battery to support subsidies here. And battery typically, as you know that the lifetime of this battery is very limited compared to that of the infrastructure. So we need to find some ways of making this battery to rework for us, right? That's what the important aspect in business model. Okay, if you are using energy trading, you should be looking at how I'm going to trade. If you are using an infrastructure, you need to look at how this infrastructure can give me a secondary market for my project over there. Okay, another example is also from the how we can use this blockchaining of the plastics over there, right? So starting from the portal which we are going to use, and how it is going to be how it is going to be translated into the revenue for you, right? This is an example of the blockchaining of the plastics. So it's the same thing, right? So you can have your own system here, how to blockchain the solar system, solar infrastructure, for example, right? Then you can come up with who will be the players and when will the players will come into the picture, right? You put a solar panel, you don't expect the solar panel to become faulty even within the 1 year, right? Probably you'll need to have players only after 5 years or 6 years of time. Within the solar panel, for example, battery are using, probably you need to have a player to come in after the 3 years of time here, right? So if you calculate this one in total there, then you will know that exactly how this business model will work for this infrastructure at last there. Okay, and of course, the last component of this how component is the market regulation, right? And as I mentioned, like the peer-to-peer to the blockchain, there should be a financial aspect there. How much TNB is going to charge for this trading negotiation or trading moderation process there, right? Several pilot systems are going there, and this one fully depends upon the vision of the individual countries towards what they see as a smart city at large here. Like for example, every country has their own smart city goal there, how they want to embed whether livability is important or social conscience is important, or you want to make the society to become digitized is more priority than the livable component over there. So every country has its own what we call as a vision building aspect here, and this regulation it depends is bounded by this smart city vision or smart nation vision of this particular individual country over there. Okay, the next component is what component, right? What should be done? What we need to do, right? When we know that why we need to do, then how we can do. Now we need to know that what needs to be the strategy, what needs to be the components, or what need to be the steps we have to do in order to make to become like a sustainability as a whole. So most of you are familiar with this picture here, which is a circular economy, right? In the conventional system, we have the linear economy. That means you produce, then you dump it. That's all right. In circular economy, what we try to do is we try to see that at every part of this cycle here, life cycle here, right? Whether it can, whether there is a residue or something waste coming out of the system here, whether you can use it for a secondary market or not. Right? This is what the circular economy is talking about. So meaning that we want to move from replace to repair, right? So we don't want to, when something is faulty, we don't want to replace it, but rather we are trying to find a value in that component to see that whether it can replace that one in the secondary market or not, right? So that's why it's become important, not alone when we talk about sustainability, people tell you have to save energy from your home. Of course, we want to save energy from the home. At the same time, we also make sure that the sustainability is starting from the production plant itself, right? How it can make the plant itself to become sustainable, right? How it can make the transmission system itself to become more reliable, right? Distribution itself is more reliable. Of course, utilization component, we have to educate the people there. But if you go and tell the people to compromise their comfort for the sustainability, they will not do. Nobody will do, right? So we have to educate the people in a different aspect. The example which I show you the next slide, next few slides, I will tell you how do we motivate a project towards a consumer point of view. Okay, so to do this one, all this one we need to do is we need to measure it, we need to monitor it, we need to manage it. Right? So of course, when you want to measure it, you need to have some sort of measuring instruments, measuring system there, right? Which is essentially a sensor, a monitoring system, essentially some sort of data network, right? And of course, some sort of analytics need to come up with a managing component over there. So what you see in this screen is a technology which we are seeing is going to be the is going to stay with us for the next 30 to 40 years. And of course, 5G. Of course, people are now itself talking about 6G at large here, and other technologies are slowly will be moving to the next level of aspect here. Like for example, brain-machine interface. We are trying to develop the brain of the drone to behave like the intelligence of the human. Right? This is one research people are doing in a brain machine interface over there, right? Like for example, if you want to pick from here for certain application, in our application, for example, you want to measure it, I want to use a sensor here. I want to monitor it, I want to use an IoT, industrial Internet of Things, or as simple as Internet of Things here, right? Then you want an actuating system that can control the mechanical purpose, then you use a robotic here. Or if you want the whole system to be automated, you push this one to here. So once I build the infrastructure, I need to know what I need to pick from this system here. Okay, I need to have a sensing system. If you want to have digital, then this managing component this monitoring component will go to the digital twin component here, right? Then probably you want to have some sort of augmented reality to visualize the system like the one I just showed in the project of Hanswada, right? Then you move this component here. But definitely these three components has to be placing somewhere within this framework here. Then you clearly know that what type of infrastructure you're developing and what type of system operation component you need to put, what type of money you need to put in order to develop this infrastructure at large here. Okay, of course, this is what you are foreseeing. We are at IR 4.0 here, which is we talk about the smart city. We are somewhere between the automation to the evolutionary component here. So automation is it can be semi or it can be full. That means you expect the system to operate on its full based on our pre-programmed system, or it can have a intervention which is a semi-automatic system here, right? In the future, what we see is like the humans will be the computers will be the human that is actually monitoring the process, and if any abnormality, the computer itself will come up with a decision process there. This is what we call as an intelligent society at large there. Okay, so you can use this framework if you feel like it is quite good, because we use this one, or at least I use this one for my system here when we develop here. Whatever the infrastructure you put here, wind, solar, name it, whatever the renewable you want to put, You have to find a cloud partner there. We can pull the data over here. Then you find a business value from there. Business value here, like within 6 months, in terms of energy production, what will be the business value? In terms of the absolute of the components which you are using here, whether it can recycle or whether it can have a secondary market. Those are the things is what we call put in the business market here. Then finally, you have to see that whether whatever the process you are trying to put here as a business model within this regulation body or not, right? So we need to do this one even before we think about developing a sustainable solution at Russia. What capacity of solar panel you are going to put? What type of battery you are going to put? So what is the lifetime of this battery? What is the lifetime of this solar panel? Right. So these are the things that is translated into ringgit Malaysia, for example, right? Translate everything into the base of this money. I'm going to use a cloud partner. How much is going to cost me the cloud partner? How much is going to be the service or support the cloud is going to be yearly basis, for example, right? Translate everything into the money you're going to spend and translate everything into the money you're going to gain, right? Within this regulation body, then you clearly know that the system you're going to put is going to have sustainable in all aspects, in terms of environmental, in terms of business money for you, in terms of the societal contribution. Seldom we don't do this. Seldom we don't do this one. That's why we find the difficulty and we come up with a different plans. That means every 5 years we come with a new plan, and still we are not able to achieve a certain milestones towards the sustainable. It's not alone in any specific country, but it is around the globe because we don't find a business value of this start point. Okay, I will take another 10 minutes to just show you example of how we address this framework, right, within a problem with a local industry over there. Okay, so this one is a very common picture you are seeing in most of our most of our industrial unit or even in your own companies, which is a centralized air conditioning unit, or some of the companies they are also using, particularly for data storage. Data storage hardware where you use a VRV, variable refrigerant, VRF or VRV, variable refrigerant volume or variable refrigerant flow, right? Typically, as a layman, what it provides is it provides the aircon or it provides the cooling effect for us, right? This is what we want to, as a layman, as a consumer, right? Those who don't know about anything about this one, is a comfort level you are having in your room or your place here, right? But as an engineer, when you look at from here, because of the non-maintenance of the certain components over here over the time, we actually pay more money to the electricity board. One way is like paying more money. The second way is we are burdening the electricity TNB at a larger aspect, because the compressor unit, the machine that is using inside, it is putting more effort. That means it's consuming more current to produce the same output there, right? It is drawing more current, to produce the same output from same cooling effect from here. Right? So this is the back end of what is happening from here. As an engineer, we should be knowing about this aspect from here. How do I make this system to become more prolific, right? More sustainable, right? So that my consumer pay less money. At the same time, the TNB is also a little bit relaxed because it's not burdening them with this unit from this particular part of that, right? So this is a bigger problem, right? Big picture over that, right? Then we approach this one with a local industry there, a big aircon player in Malaysia, right? Then we pitch this idea to them. Then I will show you that how I pitch this idea from them. All right. Okay. So what we try to do is we try to see the build the infrastructure first. Right? So what we want to do with this aircon on our typical industry is like we want this aircon to generate a healthy air flow within this space we are living in, right? So that means you should not create any hazardous gases, right? That can harm us, right? For example, the COVID situation, you know that earlier time we are telling that the aircon is one of the biggest culprit in in transmitting this COVID type of virus, right? Within the family, like when you are living in the same aircon, congested room, okay. The important part is like we don't want the air that is circulating within our room or your home to be poisonous, right? right? So that's what we need to know. That means you need to measure the quality of the air, you know, what type of gases it is releasing, whether this is within this boundary of inhaling one or not, right? Then second thing, we also want to make sure that there is a process in which I know that, okay, now the air quality index or air quality within this space is not good for my health, right? So this should be indicating to me or indicating to my service engineer at last year. So we want this one to have a system where this whole CAC system or central air conditioning system can provide data, can provide sensing data that can come up with a conclusiveness to say that, okay, this is a 70% like a disease resilient, or 100% disease resilient, or 30% disease resilient. This indication will help us to know that, okay, the infrastructure which I put in there, right, can provide health from the health point of view. It is increasing the quality of the life of the people who is there, right? So we know this is the constraint we want to do. Then we want to provide disease resilient as the variable we want to make sure, and we want the system to become like an autonomous system, right, where it can automatically based on the signals, right, automatically it can collect the data and it can push the data to the cloud, and this cloud data can be given to an external party or external data engineer, where they can analyze this data to come up with a indication, and that can reflect back to your mobile phone in your home to say that, okay, now your aircon system in your whole home, for example, right, 30% safe or 40% safe, or it can provide you a solution to say that, okay, it's time for you to change your dust filter inside your aircon so that you can increase your like your the air quality index within your home to become from 30% to become 60%, 70% or like that. So this is the first challenge we look into this system here. The second one, of course, from the engineering or energy point of view, we want to make sure that we don't want to trouble the grid at large. In a way, like a grid troubling is one thing. At the same time, as you know, that when the peak demand become higher, our slab of tariff, right, will become higher, right? For example, as a typical case in one of the industries which we do this energy auditing at large, they pay about say, for example, 200,000 for the base value, right? For the peak demand, they only utilize about 0.1% of what they use in the normal one, but they pay about 3 times of what they pay for the normal one. So that means the tariff rate is literally higher. Just to give an indication, the normal tariff is about 0.7 cent per unit of consumption. In the peak load condition, right, you pay about 25 ringgit from that. So you look at the numbers, 0.7 to 70 cent to 25 ringgit per component, right? So if you're able to reduce this peak load at a larger value, right, then you can save a lot of money for this system. So it's basically for the company, right? For the company, you can spend less money. But from the TNB point of view, TNB will be relieved because you are not burdening this TNB to give you more energy, where the fuel burning from the power station is limited because of the resources available from it. So this is way in which we can become longevity. And why this peak load is happening is because, as I mentioned earlier, because you are pushing this aircon to run at a very high pressure, meaning that it's drawing more current for the same comfort because of maybe the maintenance is not there, right? So the system become less efficient at last year. You feel the cooling there, but at the back end, you're consuming more energy from the grid overhead. So these two challenges is what we wanted to address in this infrastructure. We want to build up a system that can be disease resilient, and we want to build up it such a way that it can also create an energy or economical point of view as well. Yeah. So we combine this one to come up with what type of component that can address for this standard here, right? This is taken from the ASHRAE standard from here. Air quality index, what should be the value? Ventilation index, what should be that? Pollutant index, what should be that? Then, of course, we look at the individual component of the system there. What components we want to see: that refrigerant pressure, we want to see that dust filter differential pressure here, compressor vibration, because sometimes like the fan is dirty or broken, probably the vibration is creating a lot. Because of the vibration, the system will lose its lifetime very fast, right? and of course, at the end, it's also power quality is also what we are looking at from here, right? So refrigerant pressure will direct relate with the power quality, because you're pushing more pressure means like you need to have more work to be done. That means you are burdening the grid from here. And of course, filtering is related with your health component from here, and vibration is for the longevity of the system from here. So these are the three different three different sensors with the end effect on the power quality aspect. This power quality is derived based on these three sensing components we want to put from there. Right. So of course, power quality we measure using the current transformer and the voltage transformer, like current sensor and the voltage sensor there, right? Then from there we can use this data to come up with this power quality aspect from that, right? So then we want, of course, as I mentioned earlier, we need to have sensor embedded system, right? If you look from the operational component, you need to create three different platform, right? A technology platform, you need to also have an embedded platform, and finally you need to have an AI platform also, artificial intelligence platform also, right? So we convert this one as a layer by layer aspect from here. What type of sensors we need to use, what type of controllers we want to use, how the sensors and the controllers needs to have an intelligent system there. So input you take from the intelligent, making this IoT, that is intelligent Internet of Things, to become like an intelligent Internet of Things, or you can call as an industrial Internet of Things over there, right? Based on the decision we create from this AI layer, artificial intelligence layer from there. And then after we do this one, we want to put the whole thing into a box, right? Into a simple box that can be embedded into this a CAC unit. That means the CAC unit don't need to be completely manufactured from the scrap, but it can be refurbished so that you can embed this one into the system here, which is typically like adding, like for example, when you want to charge using your mobile charger, right? Just put in plug-in from there, right? Like that, we want to develop a module from here to use it from here. Okay, this is the typical scenario, right? You collect the data, right? Go to the cloud partner, then the decision will be taking place, and it will straight away give your information to your mobile phone to tell that what is the status of your aircon at different parts of your home, or from the industries, or even for the service engineer from there, right? This one is from the service engineer point. This is for your own personal mobile phone. You have your own app. The app will give you the status of your air pollution index, your power quality consumption, how much energy you can save, how much cost you can save from here, right? And of course, the whole thing is now become black box. This data will be translated into the a framework here. Then we come up with this machine learning or deep learning algorithm that can predict, and it can, once again, it can give back the information to the service engineer, and also to your mobile phone, to tell that when is the time for you to service your aircon, so that you can save how much of costing, right? How much of costing from that, right? Of course, you need to have partners from here, business value, how much you need to invest from the cloud side, of course, when funding agency, right? And finally also some account player to move our idea to the market, right? So we have an idea, but we want the idea to go to the market, and we need to have a player, right? So we partner with one of the biggest account company in Malaysia, right? Cloud partner, of course, because we are academic, we partner with freeware, right? Cloud partner from here, and of course, TU is providing the facilities for us to utilize their aircon system from that. Okay, in our case, this is what our plan over here. Is a bigger plan, right? Bigger plan, what type of activities we need to do, what type of solution implementation phase we want to do, how it is adding to the sustainable goals from here, right? So we believe like this CAC unit will be the future aircon system. Even in your home also, it will be coming with this future system there. Of course, it can it can solve two problems. One is from this hazard itself, hazard in the sense like it can take away your disease resilient. The other one is basically the energy aspect from here, right? So these are the sustainability we are looking at aspect from the component here. And of course, when you want to see the regulation component, because we are dealing with the CAC part, we need to have some sort of definition of what is the threshold you are taking. That's why we use ASHRAE as the threshold. Then we want to implement that one into the commercial world. You need to go through several partners over that. It's very common, right? Anybody will be doing this type of things. what type of materials, technology, methods you are going to use, how it is going to be impacting your various stakeholders, right? These are the things we want to put here. So then we, based on this 4 infrastructure, right, then we put this one to the account company there and say that this is what we want to ride with you to implement the solution across Malaysia and across the possibly global value there. But of course they don't believe, right, because they are having their own. They asked us to develop a test unit for them to see that whether this one is really work for them. So what in the future, what it will happen in the test unit is like the aircon will have its own, but instead of you seeing only the temperature, now it will also have a display to tell the user to say that how much energy saving you can do, what is the air pollution index you are at current present, what will be the cost saving values, right? If you do the maintenance, right? Because we are driven by numbers, right? We're driven by money. When you say that you save $30 or $40, people will try to $30 for $40 by investing at $10. People will be tending to, like look, call your aircon, like a service engineer to come and service you, right? Otherwise, if you don't drive them with a number money there, people will seldom think about like you need in a way it's making them to feel the pressure, say that okay, this is only 30% disease free, then people will think about, oh okay, it's time for me to uh, change their account. So this is from the consumer point of view, from the user point of view. But behind the scene, as an engineer, what we are worried much is like we want to reduce the grid impact at large. By servicing this aircon at large, the consumer is saving the money, but at the same time, from electrical engineer point of view, it is actually burdening less the from the grid component, so that we have the flexibility to make this a fossil fuel which is already available, which is already depleting, to make it to become more. Okay, so the existing aircon or existing CAC system, we will refurbish. We don't model from the start, but we just make the system to become refurbished there. Then this will be collecting all the data. Then it will use to measure, monitor, manage, which I mentioned earlier there, right? It will go to the user, it will go to the engineer, it also go to the data engineer. The data engineer here is this AI part, where he will tell you how is the cost saving. It will go to the engineer once again, it will go to the user there, and it will go back to the device over there. Okay, so on scaling up, of course, we want to build this one to the bigger one. We use Taylor's University as a base here. Now we are trying to pitch this one to the funding external body there, Asian Development Bank, to sponsor for us to build the system at large here. So this is a test unit we develop with a local partner from that. Okay, so as a summary, you can have this template if you want to start to build your sustainability goal over there. Then use this template to connect it, interconnect it, and see that how this one can make it as a worth of the word what we call as a sustainability. A simple sustainable solution you do in your lab or in your company or industry, it will make a big to the city at large over there. Okay, so thank you very much for the opportunity, and I'm specific to Dr. Kanendra and I, Dr. Ahmed Farid, for accommodating me within this the IEEE PS initiative, and wish you good luck in the future aspect also there. If you have anything interesting or anything you want to collaborate with us, please do email us. My email is here. I will leave this presentation slide with the organizer. They will be sharing this one to the registered participants. Thank you again. Thank you very much.
Okay, thank you, Dr. Associate Professor Dr. Aravind, for the very interesting and informative presentations. Okay, I would like to start a very basic questions regarding the discussion that we have presentation or present today. We have a sort of different perspective of this topic, where we have the RE, we have the SDG, and we also have the smart city. So do we need to have the specific standard to combine of this kind of what we call it the term or the direction, or we can embed in any standard that viable in our country? Okay, and any comment from the panel?
Yeah, I think I go first. I think as you mentioned rightly, like when I started in 2003 somewhere, because every 2 years we can't try to come with a new jargonic word to say that okay, we are going to follow this particular goal direction. then suddenly, another two years time, it comes with a different goal direction over there. But if we look all these people's, their main intention is on the sustainability component as a base now. But I firmly believe, like, if you can stick to one goal, one part, like for example, Malaysia now is adopting the SDG goals as a base platform there, right? And if we align even the smallest project they do in the school, in the university, in the colleges, all this one is aligned to this SDG goal, and all of this one we park under this whole goals there, then we know that what is the strength of a particular country, like Malaysia, for example, whether our strength is much on the data side, whether our strength is on the cyber security or something like that. This will help us to understand where we are, where is the gap existing, and we need to put resources there to have a balance over there. Because most of us in academic, most of us will talk about solar. We talk about energy. Everybody will talk about solar because solar is easier. You buy, you just connect to something, then you can automatically can generate energy over there. But that is not going to help in the long. So it need to have a balanced of all the 17 goals there. So poverty, when you are talking about energy, you should also talk about the poverty. If we know that the poverty people are not addressing, then I think we as a government and also some of the funding agencies put more money on this poverty initiative that can make the sustainable goals to be. It has to be balanced. That is what the important aspect from. I hope I answer your question, Dr. Hari.
Okay, Dr. Nabil, may you respond? Mute. Unmute, please, Dr. Nabil.
Okay, sorry. Yes, I really agree with Prof. Prof. Aravind's comments on that. I think he's more literature in this aspect. So yeah, we do see that the SDG goal that is from UN. And when we translated it for government Malaysia to translate the objectives of the SDG, so they create their own policies, and sometimes it will be confusing and so on, misleading. So yeah, I believe that it's better to follow what is highlighted in SDG, so that it's better coordinated. Okay, and people will understand more clearly on what are the objectives that we want to follow and so on.
And how to integrate the SDG with the smart city, because as I mentioned, it's quite different area.
Yeah, it depends on how we interpret smart city. Okay, so I think having the goals is important we align our objectives based on the SDG requirements, and of course we're using technologies in order to achieve these SDG goals.
Okay. Can we have a question from the participants? Okay, the first question from Fikri Aziz. Okay, is there any direction or incentive from SEDA for biogas based on the palm oil waste, since Malaysia is the second large producer for the palm oil behind Indonesia? So it's related to the SEDA biogas direction in Malaysia. Okay, I again, is there any direction or incentive from SEDA for biogas based on palm meal waste, since Malaysia is second large producer for the palm oil behind Indonesia? Okay, any one of you can start the response the questions.
I think I am not familiar on this area, but I believe there should be any type of as mentioned by the speaker also about the cogen related aspect from there. I think any type of initiative, I think there should be some sort of incentives to be provided. So I suggest you can go through SEDA and look into that because it's not my area of work. Sorry about it.
So, Dr. Nabil, any kind of thought on that particular question?
Okay. yes, we do see some of the FIT incentive that not only for solar, so they have also incentive for biogas, for micro hydros and so on. So I believe that there is some incentive there. But that was back in when they started FIT lah in 2011. Okay, but mostly we see that the oil palm plantation they have their own generators operating their own generators. So they're producing their own electricity using the waste from oil palm. Okay. So it's quite different with what we have with PV, solar PV, where usually companies can you can prop up PV installation companies. You can company can set up PV installation, and then they can generate electricity, then they can sell to TMP. Whereas if a company they want to generate electricity based on palm oil waste, so actually the palm oil waste is already been utilized by the plantation in order to self-generate for their own consumption. So yeah, I see if we put in some incentive for that, so it will it will benefit only the plantation owners. I mean the plantations. So compared to for solar PV and so on, the benefit is quite what you call it, can be for all so that will be something that we have to look to lah.
Okay, thank you. All right, can we have a second questions? Okay, this question is dedicated to Prof. Aravind. Hi, Dr. Aravind, good morning. What is your view in reducing carbon footprint towards the net zero 2050 sustainability roadmap based on your framework that you have presented? Thank you. From Sugendran.
Okay. Thanks, Sugendran, for asking the question there. Right. I think this one is also a jargonic word once again. I say the carbon footprint net zero 2050 roadmap. But I believe like everything starts with smaller things, right? So we try to do smaller type of energy, renewable based energy in our home, in our workplace. Slowly it can reduce the carbon footprint at large. But when you talk about the bigger picture, when the government is looking at a net zero 2050 sustainability model, or the world is looking at a sustainability model 2050 there, it's a bigger one, right? It's a bigger one. It's an ambition that it's an ambition that we want to achieve this by 2050 there. But as I mentioned, this SDG goal is trying to relate to the bottom line of making the city to become carbon free. Like, as you know that in some part of China and also in India, the pollution index is very, very high. It's about 300 something there, right? And Singapore also now they are coming up with an initiative that you cannot drive every car every day, right? So they go with an alternative way of alternative number plate, like odd and even type of running number. So government is also putting a lot of effort in coming with a carbon footprint. Even in Malaysia also we are promoting most of our workplace, right, to use not to use car but rather use the public transport, right? Like the BRT, for example, the one we are introduced. The number of railway projects which we are putting up, the government is putting up, is all towards that type of carbon component. But still, like at the end, the educating is coming from our own self, right? How conscious are we in order for us to support for these global goals, right? Since we don't feel any much pollution issue there in, not to say much pollution issue compared with other part around the globe, right? So Malaysia is not very strict in putting up for example, 20 years old car, you cannot run in the car like this. But if you look at countries like even in India and go to New Delhi, you cannot see, some of the cars coming in front of you, so polluted there. If you have been to China also, you can see, that. So of course there is a lot of initiative put by the government, but it all depends upon at the end, to the common people, how we are visualizing the need and the necessity for this, making this to become like a net zero compliance. Yeah. Thank you. Yeah.
Okay, Dr. Nabil, any kind of thought, different school based on that kind of equation made on carbon footprint on 2050?
Yes. If we look at RMK 12, I think the latest one is RMK 12. They have set up this carbon footprint based on the requirements for SDG and so on. So but we see most of the policy that has been in our but that has been outlined by our ministry is still the we are continuing with the policy that they have started continuing with the policy that is existing in Malaysia. So maybe I think Prof ARAVIND has has answered the question very very well.
So can I conclude that the carbon footprint is a paramount, or is a very vital to be put in the requirement for the smart city framework? Am I right? Can or is there anything that we can add instead of carbon footprint in terms of providing the sustainable for the smart city development? Can any one of you can give any of thought on that particular issues?
Sorry.
I think we are talking about the IoT, right? We are talking about carbon footprint. Anything that we can still we need to consider in the smart city development or smart city frameworks.
Okay, I think as the word gives us, smart city means it involves the smarter of all the components involved within the city. So all the components inside the city is your infrastructure, your people, your river, for example, your lake, your waste, everything should be smarter, right? Everything should be in a way to respond on its own, which is I think is that's why I say that it's very ambitious for us to do, but somehow we have to do, because as I show in my presentation, we have to do some work, not for us, at least for the future generation of the people. For us, is now electricity is okay, we enjoy everything, but in the future, when there is no electricity, how people are going to survive, right? So this is going to be a real challenge for us, and the concern for most of our professionals and also from engineers is to how to make our future to become at least we prolong this scenario, so that people next to us, probably they come up with a better solution that can support energy from them. As a matter of fact, researchers around the world, they try to harvest energy from anything, right? They harvest energy from the air, they harvest energy from when you're running, as small as is possible then. But if you put in the scenario, everything becoming smarter, that means everything needs some sort of sensing, everything needs some sort of data, right? So essentially, if you look all this one, that means if data means you need a hardware. Hardware needs to be manufactured somewhere. That means they would have used water somewhere, right? So if you go back, it once again increases the carbon footprint to the higher aspect of that. So in a way, we need to balance out the whole aspect for a system. As a matter of fact, now if you want to manufacture one car, it will consume about gallons of water during manufacture of one car, right? That means you are actually balancing out the water for your comfort, your car. You want to run in a bigger car, but you're compromising on the water resources flashed, right? So when you talk about this car, the water engineer become upset, right? Why you want to use so much of water? We don't have even water for drinking, and you want to use it for your comfort, right? So in a nutshell, if you see the cyclic part, somewhere we will be losing carbon. We will be increasing the carbon. We have no choice about it. But we try to reduce this carbon, like maybe 2050, maybe 2060, 2070, probably we can, prolong that one to a larger aspect. So irrespective, we can talk about this IoT, we can talk about data, very intelligent system, all those things. At the end, each of these single component is making a little bit carbon footprint in the whole society at large. The only thing is like we need a balance of how we are going to balance out on this one. Yeah. I
So
hope I
you mean
answered.
balance in terms of technology and humanity
Yeah.
perspective.
Yeah.
Okay.
At the end,
Yes.
it's everything
Yeah.
for us, right? Everything for us, right? If something is not working for us, then what's the use, right? If the technology is not useful for us, then there is no point for us today. Yeah. Sorry, Nabil. Yeah. Go ahead.
Yes, carbon footprint is something that I think is fair. So let's say for example, we do say that by for example, we let's by installing solar panel, we can actually we are we can help reduce the energy consumption and so on. But then if we take a look at the carbon footprint that and we associate with installing solar panels, we can see that actually to produce the solar panel, also to manufacture solar cells, so that actually it uses a lot of energy and so on. So I remembered last time the JKR they had developed MyCRES for to assess buildings, the building carbon footprint, from cradle to grave. So they really look into on when you want to build buildings, so they look into the materials. Okay, so they calculate the carbon carbon that is generated by from the process from cradle to grave, and this will give a very clear index lah, and it's fair lah, it's a fair system, and we can compare either for example for the building, okay, so the carbon footprint for building this building is much better than this building, so it will be a fair index lah, in the sense that that's why we I think carbon footprint it will be very useful in smart city development. Yeah.
Okay, I think we have one more question, if I'm not mistaken. Minutes. Okay, from Manoj. Hi all. Thanks for the talks. It was really interesting. Okay, he just curious to know that our thoughts on the jargon of IR 4.0. What happened to IR 1.0, 2.0, and 3.0? Thank you. So we have to go back to the what we call it, go back to the old the old time.
I think thanks, Manoj. I think the word jargon, I think is the question is directed to me, I guess. Okay, I think as mentioned by Dr. Parvi, right, we need to go back a little bit of where we are, the previous time, right, the olden age. See, IR 4.0, until IR 4.0 comes, we don't worry about the 3.0, 2.0, and 1.0, right? When we hear about IR 4.0, we are curious to know what is 3, what is 2, and what is 1, right? So if you go back in very late, I think 1800s, for example, right, where you need to mobilize things from one place to another place, right? Previously, you are using cart to mobilize from one place to another place, like your go-kart, not go-kart, you're using your horse or, some trade from one place to another place, right? That is where they find that they can generate the power from boiling the water to lard, right? That's where the steam power is started. That era is what we call as an IR 1.0 era, right? Where you know that the steam power can be used to drive something that can make the transportation to move from one place to another place, right? Okay, then comes up, okay, if I'm able to transport from one place to another place, whether it is possible for me to produce something which is available at one place at large and move to the another place or not, right? So um, that means I need to increase the production at large, right? So is it possible for me to increase the production? That is what we call the mass production, right? A smaller one, maybe, for example, corn is available at one place, right? And there is another place where you can use this corn to produce oil, right? So it's important for us to harvest this one and move that one to that place so that you can make it to become like work for you. That is where we call as an IR 2.0. It talks about increasing the production at large, mass production there. So the mass production actually increases the job opportunity a lot. That's where people try to move away from their household, right? Maybe in the IR 1.0 they have only a house, a cattle, a farm. They just use this one to survive for themselves, right? Mass production is the part where they move away from this localized farm based production to become like a work at a common place there, work at a common place towards generating the same product several times there, right? That's where the mass production comes, which is IR 2.0 there. Then comes whether this mass production can be done without any hiccup or not, because humans are limited with the working condition. Probably we work for 6 hours or 7 hours. If, for example, machines can produce the same amount of whatever we do continuously for 24 hours, that means we are increasing the production a lot. When you increase the production a lot, that means you can distribute to different places, you can make more money. That means you can make it become more viable there. So that is where the IR 3.0 comes, where it becomes like a certain part of this mass production become automated, right? Semi-automated, fully automated, whatever. Okay, now the next phase is IR 4.0. So we call this IR 4.0 is because of the introduction of the internet in somewhere between the IR 3.0 and 4.0. Actually, internet revolutionized everything, right? The way we are talking today is because of internet, right? The way we can communicate to each other, even though this unprecedented scenario is because of the internet. Okay, why can't we make this internet to become work with the machine? Right, that's where they try to see that if they want to talk with a machine, that means there should be, machine is an ideal case, right? Machine is not like a human where they cannot respond, right? That means you need to make this machine to talk to you. That means you need to have some data coming out of this one. Then we want to pull this data to the internet. So if you want to pull this data to internet, you cannot use the wire, because you're communicating to different parts. So that's why this wireless technology, the cloud technology comes in. So we bundle all this together is what we call as an IR 4.0, where we believe communication and the technology come to a common point to make things to work between different parties. Different parties means between machine to machine or machine to human, or any type of communication is possible using this IR 4.0. But this one doesn't have any intelligence there. That means I talk, it transmit, it collect the data from there, or a little bit of intelligence over there, right? Either it is controlled. For example, that way of we are communicating, we are controlling to some extent there. In the IR 5.0, what we are expecting is this one is happen automatically. This is what we call evolutionary. If as a human, how one guy can control the whole process, if that human can be replaced with a machine to control the whole thing, is what we call as an evolutionary. That means we replace my brain with some other, you take out my brain, put it in some machine, and the machine responds to whatever maybe, and still my name is there while I'm enjoying my breakfast or lunch with my family. This is what we call as an evolutionary. I'm just giving an example now, but it is what the evolutionary is going to happen, which is we call IR 5.0. I think you will be hearing a lot 5G, 6G, 7G, 8G. In the literature, if you go, there are people already talking about 6G over there, right? So, but what they are trying to see is like they are trying to make the whole thing to look easier to use. If I go and tell cloud, IoT, industrial sensor, all those things, you get confused. Common man. Say the IR 4.0 compliance, right? Then people will. I mean, there is inbuilt, there is some base layer is there, but people build IR 4.0. Okay, IR 4.0 means okay, something related with internet, sensor, IoT, whatever maybe that's well. So this is how the trend will go, and you'll be hearing about this 6, 7, probably after our ages, probably 10 it will go long. We don't know. Thank you for the question. Yeah.
Okay. Dr. Nabil, anything that you want to add?
Yeah, I think Prof have explained it very perfectly. Okay.
Okay, I think we don't have any more questions. So thank you for both of you for sharing to us your thought, your experience regarding the RE in a smart city sustainability. Okay, we are already at the end of the sessions. I pass back to the MC.
Thank you, Dr. Farid, for moderating this event. I'm sure everyone had obtained valuable knowledge from the speakers. With that, we have come to the end of the program. I hope all of you could support all of our upcoming events. Please follow the IEEE PACE Malaysia and IEEE UiTM Student Branch Facebook, Instagram, and YouTube channel. Stay safe, everyone, and Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.